Hi everybody, today we are going to learn how to solve a quadratic equation by graphing. So to solve a quadratic equation by graphing, the first thing we're going to do is graph the parabola. So we'll have to find the vertex and then we can follow our growth patterns to find additional points. And then our answer or answers are going to be the x-intercepts of our graph, and that will tell us what x is equal to. So it's important to note that when you're solving a quadratic equation, there are actually three options for how many answers you can get. And graphically, I want you to understand what that looks like. So it is possible to graph and get two solutions. So that's just a parabola that is crossing your x-axis twice. So for example, a graph like this would have two solutions here and here. Now it's also possible to have one solution. Now that happens if your vertex is on the x-axis. So it would look something like this, where it just touches exactly once and turns around. So here our only solution, our single solution, is our vertex, which is also our x-intercept. Lastly, it is also possible for us to have no solution when we're solving a quadratic equation. So when you're graphing, that means that you would have something that looks like this. So an upward facing parabola where your vertex is above the x-axis, or maybe something like this, a downward facing parabola where your vertex is below. So if your graph never crosses your x-axis, then you have no solution. Okay, let's give this first one a try. So we're going to solve by graphing, which means first we need to find the vertex, because that's always our first step in graphing. So remember, we're going to use our vertex formula. X equals negative b over 2a. And we know that a is 1 and b is 4. So we substitute. So negative 4 over 2 times 1. And then we just simplify. So negative 4 over 2 is negative 2. So that's the x value of our vertex. Now to find y, let's substitute negative 2 into our function. So you can see that I am taking out my x. So I can substitute negative 2. And now let's simplify. F of negative 2. Well, negative 2 squared is positive 4. Here we have 4 times negative 2, which is negative 8, plus 3. I'm going to combine my positives first. So we have 7 minus 8. So f of negative 2 is negative 1. So that means the y value of my vertex is negative 1. So now let's graph. So my vertex is right here. I know that all parabolas follow an a times 135 growth pattern. So in this case, our a value is 1, so it follows a 135 growth pattern, meaning from our vertex, we go up 1 over 1, up 3 over 1, and then up 5 over 1 if there's room on your graph. And then let's make our parabola. So there you go. So now all we need to do is find our x-intercept. So I can see we have one x-intercept here and one x-intercept here. So those two x values are my two answers. So this is a case where we have two solutions. So we say x equals negative 3 and negative 1. So these are the two solutions to this quadratic equation. Okay, so go ahead and pause the video and see if you can try this next one on your own. Okay, let's check our answers here. So first, make sure you got the correct vertex. Your vertex should be at 4, negative 4, so you can see the work here. So here's my vertex, and I follow my a times 135 growth pattern. So I go up 1 over 1, up 3 over 1. Goes off my graph a little bit, but I just added an extra tick mark. And then I reflected that on the other side. So you can see that my two x-intercepts are at 2, 0, and 6, 0. So my answers are x equals 2 and x equals 6. Okay, we're going to try another one together. This one is a different type of a solution. So let's start by graphing it. So again, let's find the x value of our vertex. So here we do -2 over 2 times -1. Our a value is -1. So here we have -2 over -2, which is +1. Let's find the y value by substituting. So let's find f of 1. So we have -1 squared plus 2 times 1 minus 3. I want to remind you that we're always going to start just by doing our exponent. So that negative sticks there. 1 squared is 1. And then I'll multiply in my next step. So we have -1 plus 2 minus 3. So f of 1, if I combine my negatives, it might make it a little bit easier. So we have 4 negatives, so it's just 2 minus 4, which is -2. So you can see here that our vertex is 1, -2. So let's plot that point. So we have 1, -2. Now our growth pattern, again, is always A, which in this case is -1 times 1, 3, 5. So our growth pattern is -1, -3, -5. So from my vertex, I go down 1 over 1, and then I would go down 3 over 1, which goes a little bit off my graph. And then if you connect your parabola, it looks like this. So here's a case where our vertex is below our x-axis and we have a downward facing graph because of this -a value. So you can see that it never actually crosses our x-axis. So this is a case where we actually have no solution. And there you go. Okay, let's try one more together. So again, let's start by finding our vertex. So here we have x equals -b over 2a. So I'm going to substitute b with -2. And I'm going to substitute a with 1. So we get 2 over 2, which is 1. And then let's substitute x equals 1 into our function to find our y value. So 1 squared minus 2 times 1 plus 1. 1 squared is 1, minus 2 plus 1. So this gives us 2 minus 2, so f of 1 is just 0. That means our vertex is at 1, 0. So you'll notice here that our vertex is actually on our x-axis. So let's finish graphing. So our a value times our 1, 3, 5 growth pattern gives us a 1, 3, 5 growth pattern. So I go up 1 over 1, up 3 over 1, and then I can reflect that over my axis of symmetry. And then if you connect your graph, you are all done. So since our vertex is on our x-intercept, you can see that we're actually only crossing one time. So this is a case where we only have one solution, and that solution is x equals 1. Okay, that is all for today's video. Thank you so much for watching.